Okay, so part A here, arctan 1. That means the angle whose tangent is 1. And remember on your unit circle, all these points, cosine of theta, whatever that angle is your x coordinate. So like for cosine 30, that is square root of 3 over 2. Your y coordinate is your sine. So sine 30 is 1/2. And it just depends on what quadrant you're in to tell you whether it's positive or negative. So in the second quadrant, if you have 150 degrees, your cosine is negative square root of 3 over 2, and your sine is 1/2, because in the second quadrant, y is positive because you're going up, x is negative because you're going to the left. In the third quadrant, x is negative and y is negative because you're going left and down to get into that quadrant. And then in the fourth quadrant over here, x is positive and y is negative. These angles are all, these coordinates are all the same for all 4 quadrants except for the sign on them. Positive, negative, just depending on what quadrant you're in. You want to notice that the angle whose tangent is 1 is on the unit circle. And as you get to know the unit circle better, you'll realize that. And that is because at 45 degrees, or any angle that is related to 45 degrees, y over x, that's tangent, is square root of 2 over 2 over square root of 2 over 2. And that is 1. So the angle whose tangent is 1 is going to be 45 degrees. Now, we have to know that the range for arctangent, each one of these inverse functions that has a capital A on it, arcsine, arctangent, arccosine, has a specific range for the answers. The range for arctangent is negative 90 degrees to 90 degrees. And so that means that our answer for any arctangent question has to be in this range. 45, which is what we just said, the angle whose tangent is 1, is 45. Now there's another angle whose tangent is 1 over here, 225, because negative square root of 2 over 2 over negative square root of 2 over 2 is also 1. However, that is not in this range. 225 is not in that range. So our answer is going to be 45 degrees. All of these problems, we have to know the range for each capital A inverse function. So the range for arcsine is the same as the range for arctangent, negative 90 to 90. So anytime you see an arcsine question, your answer has to be between those two numbers. The range for arccosine is different. It is 0 to 180. So anytime you see a question with arccosine with a capital A, your answer has to be between 0 and 180. And the reason for that is that if we only used negative 90 to 90 for the angles whose cosine was something, we would never be able to have any negative cosines, because cosine is always positive between 0 and negative 90 and 90. So we have to use 0 to 180 for our cosine. That doesn't really apply to this particular problem, but if we had something like the angle whose cosine is negative square root of 2 over 2, for example, that would have to be 135. Because that's the only angle whose cosine is negative square root of 2 over 2 in the range 0 to 180. If we had arcsine sine, and this is with a capital A, we'll say we had 1/2. Let's say negative 1/2. The angle whose sine is negative 1/2 is right here at 330. However, we can't call it 330. We have to call it something between negative 90 and 90 because this has a capital A. So we will call it negative 30. So hopefully you see what I mean about the ranges for arc cosine, arc sine, and arc tangent. Your answers have to be in those ranges. All right, so part A involves the unit circle. Part B and C do not involve the unit circle because the angle whose sine is 3/5 is not something we have memorized on the unit circle, and the angle whose tangent is -3 is not on the unit circle either. So we have to use a different way for those particular problems. So for part B, we're looking for the tangent of the angle whose sine is 3/5. All right, so first of all, we're going to find the angle whose sine is 3/5. So here's an angle in a right triangle. If its sine is 3/5, that means that opposite over hypotenuse is 3/5. So that's what that angle looks like. To find the other side, the adjacent side to that angle, we use the Pythagorean theorem. So we'll call that x. X squared plus 3 squared equals 5 squared. So x squared plus 9 equals 25. X squared equals 16. So x is 4. So this is what we call a 3, 4, 5 triangle, and it's a triangle you could easily memorize. So this side is 4. All right, now that we have found the angle, and we don't know what the angle is, we don't need to know what the angle is. The question's not asking us what the angle is. It's asking us what the tangent of that angle is. So now that we have the 3 sides of the triangle, we can say what the tangent is. And the tangent of this angle is opposite over adjacent, which is 3/4. Now, what we have to remember is that the angle whose sine is 3/5 is in the first quadrant because negative 90 to 90 are the angles that are in the range for capital A arcsine. So we can think of this as being in the first quadrant. And so therefore, we know our answer is right because it's positive. Tangent is positive in the first quadrant. So we don't have to worry that maybe it's negative. So part C is asking us for the cosine of the angle whose tangent is -3. Okay, so again, we're going to have an angle in a right triangle. We're told that its tangent is -3. It has to be in the fourth quadrant because tangent, that is where you have the angles where tangent is negative, because remember, arc tangent with a capital A goes from -90 to 90. So that's fourth and first quadrants. All right, so when we draw the triangle and put the sides on it, we don't have to put that negative, but we will figure out in the end whether our answer should be negative or positive. All right, so the sides of the triangle would never be negative just because it's a triangle and we're talking about distances. Okay, so we're looking at the angle whose tangent is -3, and in this triangle we'll just say 3. So tangent is opposite over adjacent, so that means 3/1 for this particular angle. We're looking at the angle whose tangent is 3. So opposite over adjacent, 3 over 1. Using Pythagorean theorem, 1 squared plus 3 squared is equal to 10. So that means that the hypotenuse is the square root of 10. And now we want the cosine of this angle. We don't care about the angle itself. We don't really want to know the angle itself. We just want to know the cosine of it. And it's a good thing we don't want to know the angle because we wouldn't be able to find it on our unit circle. So the cosine of this is going to be adjacent over hypotenuse. So the cosine of this angle is 1 over the square root of 10. And just to make sure this is a positive answer, it's supposed to be positive, we just remember that we are in the fourth quadrant, and in the fourth quadrant, cosine, which is x, is positive. And then we just need to rationalize our answer. So that is the square root of 10 over 10. Okay, so for 24C, we have f of x equals 3x minus 5 and g of x equals 2x squared. And we're trying to find f circle g of 2. And what f circle g of 2 means is f of g of 2. So that means you want to find g of 2, and then whatever that is, you want to plug that answer into f. So g of 2 is equal to 2 times 2 squared, which is 2 times 4, which is 8. Now we want to take that and plug it into this function. So now f of 8 is 3 times 8 minus 5, which is 24 minus 5, which is 19. So all this circle means is f of g of x. So f of g of 2, which is this, which is that.